Hello everyone, welcome back to my channel and I'm Akshaya pursuing second year engineering in SVCE Bangalore. So today I have come up with one of the important topic in the ADA, that is the algorithm and design part, that is the bubble sort with the time efficiency, one of the important topics. So let's get started. Coming to introduction to the bubble sort with the time efficiency. So bubble sort is a simple sorting algorithm. First, let us understand what is bubble sort. It is a simple sorting algorithm that repeatedly steps through the list, compares the adjacent elements and swaps them if they are in the wrong order. So the basic example, the image I have depicted here, so 5 greater than 1, so interchange. So that is the thing I've mentioned here. If the adjacent element, swap them if they are in the wrong order. Yeah, and despite its simplicity, bubble sort is not efficient for the large data sets. Point. So, despite its simplicity, bubble sort is not at all efficient for this large data sets, and the time complexity of the bubble sort is of n to the power square order in the worst and the average cases. So, this is the time complexity being done in the bubble sort cases, and is the best image I have been depicted here. So, this is about the introduction, and we learned about what is the bubble sort. So basic concept of the bubble sort. Let's understand the basic concept behind the bubble sort. Bubble sort gets its name because smaller elements gradually bubble to the top of the list. Easier to understand. The algorithm compares adjacent elements and swaps them if they are in the wrong order and moving the largest elements into its correct position. And this process is repeated until the list is in a sorted way. And the main purpose of the bubble sort is to clear the wrong order and make them in a perfect way. So if the process will be repeated until the given list is sorted. This is about the basic concept behind the bubble sort. Time complexity of the bubble sort. So coming to the time complexity of bubble sort, the worst case time complexity of the bubble sort is the n to the power of square, which occurs when the list is in the reverse order of it. In the best case scenario, when the list is already sorted, the time complexity is just n. So worst case, when it is in the reverse order, it is to n to the power of square. So when it is in the best scenario, already sorted, so the time complexity is n. The average case time complexity of the bubble sort is also n to the power of square. Average time complexity of the bubble sort is also n to the power of square. Space complexity of the bubble sort. So bubble sort has the space complexity of 1 because it only requires only one constant amount of extra space for a temporary variable. A very important point and can be asked for the Viva questions also. The bubble sort has a space complexity of 1 because it only requires a constant amount of extra space for the temporary variables. This makes bubble sort a space efficient sorting algorithm. And the space complexity does not depend on the input size. Very important point. The space complexity does not depend at all on the input size. This is about the space complexities and space complexity is 1. And we saw about the time complexity of the bubble sort. Best case, unsorted order, it is n square. Worst case, best case, in a sorted way, it is just n. Adaptive nature of the bubble sort. Bubble sort is an adaptive sorting algorithm because it can efficiently handle partially sorted list. And if the list is nearly sorted, bubble sort can complete in n time complexity. However, in the worst case scenario, the adaptive nature does not significantly improve the time efficiency. Yeah. So the adaptive nature is nothing but it can efficiently handle partial sorted list also, and it nearly sort of bubble sort can complete in n time complexity. However, in the worst case scenario, the adaptive nature does not significantly improve the time efficiency too. Yeah, stability of the bubble sort. What is the stability coming to this? Bubble sort is a stable sorting algorithm, meaning that it preserves the relative order of the equal elements. So it is called as the stable of the stability of the bubble sort. If two elements have the same value, they will not be swapped during the sorting processes. This makes bubble sort suitable for sorting data with multiple key values. Best image I've depicted here 10, 20, 30, 10, 10, 20, 20, 30. So sorting is stable because the order of the ball is maintained when values are the same. The ball with the green color and value 10 appears before the orange color ball with the value 10. Similarly, order is maintained for 22. Same number, stable. Yeah. Limitations of the bubble sort. What could be the limitations of the bubble sort, my dear friends? And bubble sort is not suitable for the sorting large data sets due to its n to the power of square time complexity, and it is inefficient compared to the more advanced sorting algorithm like quicksort or the merge sort. Very important point I have mentioned here. It is inefficient compared to the more advanced sorting algorithms like quicksort or merge sort. Bubble sort should be used for educational purposes or sorting small data sets where simplicity is preferred over efficiency. Point. So improvements to the bubble sort. What would be the improvements that we can do here? Best images I have depicted here. Optimized versions of bubble sort exist, such as the cocktail shaker sort and the comp sort, which improve the performance of the algorithm. These variations reduce the number of comparisons and swap required, making bubble sort slightly more efficient one. However, bubble sort remains one of the least efficient sorting algorithm for the large data sets compared to the least itself. So sorting order, and the best image have been typically here. What are the real world applications of the bubble sort? Very important slide and very important point. Let's see. Due to its simplicity and ease of implementation, bubble sort is commonly used in educational setting to teach the concept of the sorting algorithms. Very important point. Bubble sort can be used for small data sets or simple application where efficiency is not at all a critical factor. In real world scenarios, bubble sort is rarely used in production environment due to its time inefficiency. So here the cases is where the practical application can be used. So that's what I've mentioned here. So coming to the conclusion part. So part we learned about what is bubble sort, coming to the importance of the bubble sort, time complexity, what is the best case, what is the worst case, real world application. So coming to the conclusion, it is a sorting algorithm with time complexity of n squared that is not suitable for the large data sets. While bubble sort is easy to understand and implement, not efficient compared to the other sorting algorithms. Understanding the time efficiency and limitations of bubble sort is essential for choosing the right sorting algorithm for a given scenario. Yes, of our content. So this was about the bubble sort and the time complexity. Hope you guys got an idea about the bubble sort and the time complexity thing. Thank you so much.